Hello and welcome back. So in this video, we are going to understand few of the key concepts and some of the definitions related to the neural network. So first of all, we are going to define all these things in this video: neurons, synapses, weights, and activation functions. So let's see what is a neuron. So neuron you can imagine as a tiny processing unit. I mean a small computer. So it receives input, performs a calculation, and produces an output. Right? Suppose you want to give the image of a cat, and if you want to identify, if you want your model to identify whether it's a cat or not, then in that case, the image of the cat will become input, and whether it is a cat or not, that will be the output, right? So you can consider the entire processing unit which is performing this task to identify the cat. So that way you can understand that neuron is just a single processing unit, a tiny processing unit. But in essentially what happens that when you pass the image of a cat, then in that case, different parts of the cat, they are identified by the neural networks. So neural networks is just like a layer of neurons. Different neurons, number of neurons are they are placed at a particular level, right? Suppose at the top level, we have first layer, and then the second level we have the second layer, and at the third level we have the third layer. So the first layer can be uh, responsible for identifying the face of the cat, whether the face resembles to a cat or not, right? And then we can have other layer where we are identifying its stomach, the fur around the body, and then we can at the third layer we can identify that whether the legs are looking like the legs of the cat or not. How much confidence we are that yes, this is the leg of the cat or not. So this way, different neurons they receive the input. Like first layer of neurons is receiving the input for the face. Second layer is going to calculate whether the stomach and the fur around the body is of a cat or not. But if we are not able to find out at the very first layer that yes, this is not the face of the cat, then is there any need to go to the second layer? Obviously no. So these are the things which happens, right? Which are basically the essential concept behind the neural networks, how it calculates, right? So let us see with the help of the further definitions, and you will understand what we have, understood till now and how we can connect it. So the first component is the input. Input you can consider as a signal, right? Just like in case of human nervous system, one neuron sends the signal to the other neuron passing the information, right? Similarly, in our case, when we are talking about the neural network, in our case, this is data. Signal could be compared to data. It's a metaphor for data in case of neural network, right? Signal can be considered as a metaphor for data in case of neural network. So the inputs are received by the neurons, right? And either from the external source or from the other neurons, these data could be fetched or could have been received, right? At the very first layer, the data is received from the external source, right? Like the input that you provide, whether this is a cat or not, something you are asking. So that is the external source. And then comes the neurons. The other input is neuron. When from the external source, you have got some data, and based on that data, which your neuron has received, if it is able to process and come up with a result that yes, this was the face of a cat, then in that case, that particular neuron has done its task with the confidence that yes, this is the face of a cat, and now it need to send the signal to the other layer of the neurons, right? Because face has been identified. Now the stomach and the fur around the body and the size of the stomach compared to the head, that all need to be calculated, right? So the second layer will be activated, and the output from the first layer will be that yes, I have identified the image as the containing the face of a cat. Now the second layer need to do its work. So this way, the external and internal sources are there from where these neurons are getting the information, or these neurons are getting the input. Okay. Now comes the weight. Okay. So every input that you provide, right, that has a certain weight, because every input that you provide, like when you are providing a cat face, right, when you are providing a cat image, so in that case, what is more important to identify a cat? The highest weight should be of the face, and then there the highest weight should be of the eyes, right? Then the nose, and then the mustache, tiny mustache around the face, right? So all those things all those components in a image, they could have different weights. So these input weights are assigned to the various features, right? For example, if you are training your model, right? Then if you are training your model to identify a cat, then in that case you need to tell it that what is the component of the input, like what is the input, the face of the image of a cat. And now what is more important? The face is more important, right? So face input part, the complete input part is a cat. But yes, the part of the input is face, the stomach, the fur, and the legs, just for the example. So everything has a different weight. The most important thing is the face of the cat, right? So face will get higher weight while you are training your model, right? So face is getting higher weight, then stomach is getting, compared to lower weight, and then legs, they have the least weight, right? So this way we provide the weight to the input. Input means that input which you are using your model to train, right? So in that case, what happens that you are providing your model that yes, when you are learning the things, then you need to give the highest weight to the face, right? So that way you are training your model that yes, what should be the weight for it for of different areas of the image, so that it can learn, right? Summation. Now all the weights are summed up, all the different weights are summed up. Okay, this is like adding up all the information it has received, but with each piece of information having a different level of importance. So I have already discussed this. Like each piece of information, one piece of information will be the face of the cat. The other piece of information is the stomach and the fur, and the third piece of information is the legs legs, right? So all these different components and their weights, they are summed up and they are collected together. This is called the summation. And after summation comes the activation function. What is the activation function? These summed up values are then passed through an activation function. I mean, all these values that you have collected for the different weighted inputs, they are passed to the activation function because it will perform the real task. This function introduces non-linearity into the neurons output. Non-linearity means, I mean, the complex things are there. These are the complex things, identifying the image, face of a cat, then identifying the stomach, fur, all these things. These are the complex things. And, when a model is training itself, when you are training a model, then in that case, it it just plot the data. It just create the graph of the data. It just create the, either it uses the matrix to, see the dispersion of the pixels, right, all around. So in that case, the data could be a complex thing, right? So to remove this complexity, the activation functions are used. Activation functions introduce the non-linearity into the neurons output, right? Non-linearity is needed because if things are linear, then obviously the things will not be easy for you to identify, like the face of the cat. That will not be easy for you to identify if you are a machine learning model. So that's why we have to introduce a non-linearity, need to make it more complex, and then we need to do the complex training. That's why we need to introduce some kind of non-linearity so that the training can be more intensive with more set of data which is not that easy to identify, right? So allowing the network to learn complex patterns. Okay, this is just like if you practice, the tough questions, you will become a master. You will become more confident. If you are learning maths and if you just do the simple examples or the simple questions which are directly where the values can directly be put into some kind of formula, then in that case you are not going to become a good mathematics student. But if you are going to understand the mathematics, with respect to different um, complex problems, then those complex problems will uh, make you more stronger in mathematics. So that's why to be able to identify the complex images, complex patterns of the images, because cat will always not will come, like the face will not be in front of you always. when it is provided to the machine. It may be that you are providing the side face of the cat. It may be that you are not providing the side face, you are providing the back portion of the cat. Some cat is sitting and you are just providing the back portion of the cat and you are asking whether this is a cat or not. So these are the complex things. These are the complex patterns with respect to an image. So introducing the non-linearity and in turn you are introducing the more complexity so that your model can learn the complex patterns, right? So these complex patterns are identified using the activation functions. So these are the three activation functions: Sigmoid, ReLU, Tanh. So we are going to understand these in the coming videos. But yeah, as of now, you can just understand what is their name. So these are the three functions we are going to see. If you have studied mathematics, then you might be aware about these functions, right? If you have worked on the higher mathematics, then these functions will be known to you. Then comes the output. The final output of the neuron is the result of the activation function. This output is then sent as input to other neurons in the network. So this is how it works. So I hope you must have understood. So in a sense, a neuron takes in information, weights it, combines it, and then decides whether to fire based on the activation function. Okay, so with this, I would like to conclude this particular video. I hope you might be understanding it clearly, what we are trying to understand it here. So we are going in much detail, like whatever level of details are possible, I'm going to tell you here. So be with me. We'll meet in the next video. Till then, have a nice day.